Hi, everybody, and welcome back to my channel, Numbers with Nora. This is a math tutoring channel that helps you with all your math questions, needs, homework help, whatever, and all types of math. For this video, I'm going to be doing another geometry lesson. This is going to be chapter 10, lesson 10.5. We're going to be doing trigonometry and area. All right. So the book I'm going to be using is Geometry Common Core textbook. I'm not sure which version this is, but I'm going to sit there and put a link to which book I'm using in my description. And I also want to give a shout out to Charlie13_MC. He asked me to go over this chapter. Charlie, if this is not the correct chapter subject, just let me know, and I can make another video on the correct subject. All right. So let's go ahead and get into it. So like I said, with this chapter, we're going to be doing some trig and area with geometry, and the objective is to find the area of regular polygons and triangles using trig. All right. So the one thing I do want to note that's essential is vocab, and go over some of the vocab that we're going to sit there and see when we do some of these problems. So the first one is going to be a isosceles triangle. Isosceles triangles are two sides, is when a triangle has two sides that are congruent. Okay. So we're going to see some of those. Remember, radius is a straight line from the center to its perimeter. All right. Mostly they talk about radiuses with circles, but some of these polygons, we're going to sit there and create radiuses for them as well. All right. The apothem, this is important because we're going to use this a lot. It's a line from the center to its perimeter. A line from the center. Oh, sorry. A line from the center of a regular polygon. If I can spell today. Of a regular polygon at a right angle to any of its sides. Okay, and we're going to sit there and see an example of that in all of these. Okay, because the apothem is really important when you're using trig with these, because we want to create a right angle or a right triangle. And again, just some recap: a regular polygon, that's just going to be a polygon with congruent sides and equal angles. Okay, so whenever they say it's a regular polygon, you can always know that all the sides and all the angles are going to be congruent. Right, now that we have those vocab things in line, let's go ahead and jump right into problem 1. Okie dokie. So for problem 1, what they want us to do is, let me get my pencil ready. All right, so what is the area of the regular nonagon? So a nonagon is actually going to be 9 sides, right? So what is the area of a nonagon with 10 centimeter sides? Right here, they have a drawing for us that we can see. All right, so the first thing is we're going to sit there and find the area of a triangle and use that. So remember the formula for an area of a triangle, because that's what we're going to try start. We're going to sit there and draw a triangle within our polygon and then sit there and use that to help us find our area. So area of a triangle is 1/2, and we have base times height, right? Except for our base, we're going to use something different. And for our height is actually going to be our apothem, which our apothem is right here. So first, let's go ahead and focus on finding this, like creating a right triangle out of this one right here, right? So the first thing we want to do is notice that when we do have, when we want to find the angle right here, all right, because we want to find this angle when it's not given to us, we can do that with a simple formula. All we're going to do is remember all the way around a circle is 360. So we're going to do 360 divided by how many sides we have in our polygon, which is 9. Right. If you do that in your calculator, 360 divided by 9, I believe that's going to give us 40 degrees because we are finding an angle. Right. And don't get tripped up because once we find that angle, that doesn't mean we found the angle for this triangle right here. No, we found the angle for this whole triangle, okay? So all of PCR. I don't want all of PCR. I want only PCS because this is the triangle that I'm dealing with, right? That I'm worried about and I want to calculate. So to do that, all I have to do is divide this by 2 because that apothem sits there and cuts our angle equally, right? So 40 divided by 2, that's just going to sit there and give me 20 degrees. Okay. So what I found right now is for this angle right here, which is going to help us with our trig stuff, 20 degrees is 20 degrees, right? I have a 90-degree angle right here, which is created by my apothem, CS, that's fine. So the next thing I want to do is I'm going to sit there and do some annotation so we can understand this a little bit more. Okay, so this is going to be my height. Okay. My hypotenuse is always diagonal from my 90-degree angle. Right here, down here, PS, this is going to be my op. I always find my opposite side from the angle that I have. It's going to be the opposite, okay, from that angle that I have. So this is my op. And then whatever side is left over, that's going to be your adjacent. Okay, that's going to come into handy when we pull out our trig. Right, now that I have that annotation. So like I said, we sat there and found that angle. That's going to help us out. Now let's finish finding the base, right? So for this base, what we do is we find the parameter. The parameter is when we sit there and add up all of our sides of our polygon. All right. And so for that one, that's just going to be, let's see. So if I add 10 and this is a 9 nonagon, so 9 times 10 is going to give me my parameter. P equals 9 times 10. Okay. And I'll just write this is going to be our P. All right. So that equals 90. Oops. Hold on just a second. All right, so we'll be able to sit there and use this and this formula after. So with P, with finding our base or whatever, it's just going to be our parameter. Our parameter is linked when we add up all of our sides of our polygon, all right? So next, let's focus on the height. To find the height, this is where we're going to have to use the trig because our height is really our adjacent side. Our height is that apothem right there, okay? So next, let's go ahead and sit there and find that apothem. To do that, this is where we have to bust out the trig, okay? So I did want to add a trig chart on here. Online. Let me see if I can find the trig symbols. What do we call them? Trig. And all of you guys should have these handy true trig ratios. This let's see if I can find them. Trig ratios, here we are. I'm just going to take a screenshot of it and put it down here. Right. I should have done this before the video, but it's okay. All right, so these are where I'm going to sit there and get most of my trig stuff from. So we have sine, opposite over hypotenuse, cosine, adjacent over height, tan, op over adjacent, and so forth. That's why I sat there and marked up my triangle from the get-go. So I know which side and which sign I'm going to use. or which trig ratio I'm going to use. Okay. So for this one, I always like to sit there and see what trig ratio I'm going to use by what I have, right? So I do have my little angle right here, which is good. And also I do have this little base right here because this whole base is supposed to be 10. But since I cut that in half, this is just going to be 5. Okay. They also have another picture down here showing what I'm doing too. I know I'm using this one, but you can look at this one to see. So we're going to find our apothem A, okay, using trig. So this means that I'm trying to find my opposite side and my adjacent together. So let's go down and see what trig sign has op and adjacent together. It's going to be the tan. So tan, I can sit there and use my op and adjacent, okay? So now I'm going to do tan. And you always do tan of the degree that they gave you, right? That you set up your triangle with. The degree that we set up our triangle with, because this is my opposite within accordance to my degree, that's going to be 20. Right? And that equals, what is tan again? Op over adjacent. So my op is 5. And then I don't know what my adjacent is, so I'm just going to mark that as X. Right here, I just use basic algebra to sit there and simplify this down. What that looks like is I just multiply both sides by X. So then I get X tan. Some students get confused, like when we have the trig there, but you're just using basic algebra to solve this down. 20 equals 5. All right, but I want to isolate that X to be all by itself. So that's when I sit there and divide both sides by tan of 20. All right. You can skip through this part if you already understand how to do the algebra here. I just get a lot of students who forget how to do this when trig is involved. Okay. 20. That means these cross out. Now your X is isolated and you have X equals tan. Oh, excuse me. Oops. X equals 5 over tan 20. Okay. So that's what my apothem is. And we're going to sit there and put that in the calculator later. I'll show you how to put that in the calculator as well. And you do want to make sure your calculator's in degrees, right? So now we found our apothem. So now that we found our apothem, that's going to be our height. So now I can go ahead and find my area. And so what that's going to look like is it's going to be my area equals 1/2 times my base. My base is just the perimeter of my polygon, which is 90. We found that. And then times my height. All right. And remember, the height is my apothem. That's going to be the 5 over tan of 20. Okay. All right, so let's go ahead and plug this in our calculator and see what we get. This is that other parentheses right there. Sorry, that looks a little weird. So let's pull up the calculator. Here it is. Let's put it all in. I always, since I'm using this calculator on my computer, if you use a scientific one, it's like a lot easier to use, okay? So I'm gonna put my things in parentheses just so I make sure everything's right. So I have 1/2 times 90 times, and then I'm gonna use my parentheses. I have 5 divided by, and then I'll use my parentheses again, 20 tan. All right. And I'm going to get 618. And then when I want to round, okay, find your place, look like next door, 5 or more, raise the score. Right now, I'm just going to round to the highest 100. So just 118 is going to be my answer. So, or 618 is going to be my answer. So I'm going to put A equals 618. And this is cm squared. And that's my answer. So the gist of this is what we're doing is first we want to sit there and find our area. So our area is 1/2 base times height of a triangle. Our base is just our perimeter, right? So we find out how many sides there are and then sit there and find the perimeter, which is just adding how many sides or multiplying by how many sides there are. Then after we find a perimeter, we want to find our height. Our height is basically our apothem, which is this side right here. And that's when we bring in the trig. All right. And then we sit there and plug this all into our calculator, and that's it. All right. And then also remember to find this angle right here. You're going to sit there and do 360 divided by how many sides you have. All right. If you want, just for the sake of time of this video, try to do one by yourself by doing what I just did and set it up the right way. If you have any questions, leave something in the comment. All right. But I also want to get to number 2. All right. So for this one, finding the area, a stop sign is a regular octagon. The standard size has a 16.2 inch radius. What is the area of the stop sign at the nearest square inches? So we're doing the same thing, except this time they're nice enough to sit there and give us the radius. Okay. So doing our steps again, it's easier when they have the diagram to give us. Right here, they were nice enough to go ahead and give us this angle. But again, remember, if you didn't know, if they didn't give us that angle and you didn't know how to find it, all you do is 360 divided by how many sides you have. Okay, with this one, we have 8 sides. So 360 divided by 8. Sit there and do that in your calculator, and then you will get 45. 45 only gives me the whole thing, right? 45 degrees. So that would give me the whole thing here. So I would have to do 45 divided by 2. If I do 45 divided by 2, I'm going to sit there and get that angle 22.5 degrees. Okay. That's just in case you're on a test and you forget how to find that little angle if they don't give it to you. Okay. That's how you find it. All right. So they were nice enough to sit there and give us this angle. They have our radius right now. Again, I always like to annotate my right triangles. The side opposite of my right angle is going to be my hypotenuse. They give us this angle right here. The side opposite of the angle that's given, that's going to be my opposite side. And then the remaining side that's left over, that's just going to be my adjacent, okay? Which is this, or height, or adjacent, or this side right here. Now that I have that all nice and annotated, I can sit there and figure out what I'm going to do to find my height and my base. Because remember, the only formula that we're using for our area is we're finding 1/2 our base, which is our perimeter, and our height, which is our apothem, right? Now this one is going to be harder to find our perimeter because they don't give us what our sides are. So we're going to have to sit there and find that, all right? So let's find our sides first, okay? Let's find our B, our height, or our perimeter is how we can think about it. So in order to find that, since they don't give us our sides lengths, we're going to have to use trig, all right? So I want to sit there and involve my op because that's going to help me find my side. And then I'm given hype. So I want some trig sign that involves hype and op, all right? Whenever I'm doing my homework, I always have these little trig ratio sheets next to me so it's easier, but slowly but surely you're starting to remember them, all right? So the one trig sign that uses op and hype is going to be sine. So that's op over hype. So we're going to use sine to sit there and help us find that side. So I'm going to do sine. Remember, it's op over hype. Sine of my degree is 22.5. And then my op, I don't know what it is, so I'm just going to label it as X for now. My height, they give me that. It's my radius. That's going to be 16.2. Then again, I just use algebra because I want to isolate my x. I can do that by multiplying both sides by my denominator, 16.2, and then crossing out that on the side. That's going to give me, I'm just going to write my x on the left-hand side. That's going to give me 16.2 sine, because it's just being multiplied by my sine, 22.5. Okay. Perfect. If I sit there and solve for this, I'm going to sit there. I'm only getting my x right here. Now, remember, to find my perimeter, I need the whole side, and then I have to sit there and multiply that whole side by 8. All right. So if I want to sit there, actually, let's go ahead and do this in the calculator and get a number for it. So if I do this in my calculator, I'm going to have 16.2 times 22.5 sine. All right, so that's going to get me 6 point. And when I'm not using all of it and I try to round, I try not to round into the end. So I always go like 4 numbers after my decimal. So I'll do 6.1994. 6.1994. Yeah. Cool. So that was just that. So remember, this 6.1994 just got me x. That's all. I need to sit there and find this whole side, right? And then multiply it by the number of sides of my polygon. So I can do that by multiplying this by 2, because if I multiply this x by 2, it will give me that whole side. So let's multiply that by 2. Then I'm going to get times 2. 12.3989. Let me just do that on my phone calculator because this calculator trips out on me. The computer one sometimes. 994 times 2. Yeah, I agree with that. That's 12.3988. Okay. And again, that just gives me all of this side. So I know each side is 12.3988. Now I need to take this and multiply it by 8 because there's 8 sides of my polygon. That's almost like adding this 8 times, okay? That's going to give me my perimeter. That's going to be 12.3988 times 8. That's going to give me 99.19, oops, 04. Perfect. And so that's going to be my parameter. I'm going to put that in place of my P, okay? I'm actually going to change this to P. I'll just put P equals. Just so we remember that's our P that we found, our perimeter, and that we're going to use that as our base. All right, so now that I found my base, I need to find my height. My height is my apothem, which is this right here, where you're going to use more trig to find that. And this time I want to find a trig function that involves my height because I'm already given my height, which is 16.2, and my adjacent. So I go back to my trig chart and I sit there and look which one involves adjacent and height. It's going to be cosine. So I'm going to do cosine of my angle to 22.5 equals, and I believe it was adjacent over height, right? Adjacent over height. I don't know what my adjacent is, so that's x over my height, which is 16.2. Again, I just use basic algebra to solve for x and isolate my x and multiply both sides by 16.2. So that's going to mean 16.2 multiplied by my cos of 22.5. Okay. Again, let's go ahead and figure out what that's going to be. Use it on our calculator right here. So I have 16.2 multiplied by 22.5 cos. That almost sounds like a radio station. Right. Then also you want to make sure, you guys got to give me the right degree. This one always messes up sometimes. Let me make sure that it is correct. Oh, that's why. No, I use cos. So let's do 16. Let me make sure. It's always tricky because you want to make sure it's in degrees or rad. All right, so let's try it in degrees. So we do 16.2 times 22.5 cosine. That looks a lot better. That looks a lot better. So 14.66 or 14.9668. That's going to be it. So 14.9668. Like, again, I like going at least 4 numbers after the decimal so I get a better accurate reading when I do it all at the end. All right, so now I have my perimeter, which I can count as my base, and then I have my height, which is my apothem, so I can go ahead and put it back into my area formula. So I go A equals 1/2. My parameter, or my base, so that's 9.1904, and then times my height, 14.9668. Those sixes are ugly, but that's okay. I plug this into my calculator and I see what I get. Most times, a lot of students mess up on the calculator work on here, so always take your time when you're doing calculator work and put in those parentheses when you think they're needed, or so on and so forth. So 99.1904 times 14.9668. Okay. That looks about right. So my answer is going to be 742 cm squared. Okay, that's my area. All right, so those are the main steps. Is you want to set up your area, 1/2 your base, which is your perimeter, times your height, which is your apothem. All right, so those are the 2 main steps: is finding that apothem and finding your perimeter. And we use trig to do so. All right, so also in this chapter, they introduced theorem 10-8. This is the area of a triangle giving side, angle, side. So remember in our earlier chapters, I believe it's 4-4, that I sit there and introduce side, angle, side, and side, 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 and angle, side, angle, and all those postulates. This kind of comes from there, okay? But we do have a theorem. Remember, a theorem in math is something that's already proved, so we can just use it. This theorem is basically stating that we can find the area of a triangle by sitting there multiplying 1/2 my sides, or they call these sides, the area of a triangle is half the product of the length of the 2 sides and the sine of the included angle. So this is also in my chapter 4. Included angle is going to be the angle that's in between any 2 corresponding or congruent sides. If there was another triangle that this was congruent to, these would be corresponding sides. But basically, we can look at our included angle as the angle that's in between the two sides that I'm going to be using, okay? So if I sit there and do 1/2 times b times c times the sine of my included angle, I can go ahead and get the area of that triangle, right? So let's look at an example of that. That one's right here. What is the area of the triangle for, again, since we're going to use theorem Tim-8, which is up there, I can sit there and find the area of this by doing 1/2. And this is just basically substitution. 12 times 21, since we are doing products or multiplication, it doesn't matter if I put 12 or 21 first. Okay, they can be switched around. And then this is time the sine of 48. Right. Now, most of this is just calculator work, okay? So for calculator work, I'll show you how I plug it in my calculator. In parentheses, 1 divided by 2, that's my 1/2. Multiply it by 12, multiply it by 21, multiply it by, I'm going to put in parentheses, the sine of 48. Okay. And then I'm going to get 98.6362. I'm going to go ahead and round that off. And let's just say that is 94. Okay. 94 cm squared. All right. Again, if you need help with number 3, or this one down here, let me know in the comments. I can sit there and make another video on that. All right. Again, if you need any help, any questions, homework questions, and I do all types of math, college math, algebra, algebra 2, just put it in the comments. I'll make a video on the subject that you need help with, or I can sit there and answer right back to your comment. If you just need help and seeing step by step how a problem is done, I can help you. All right. Thanks, guys.